Cool. I think we're live. Hello, everyone. Hello, Niels.
Hey, Sage.
How was San Francisco?
That's good. Yeah, it's just for a day, but it's always nice to go out there.
Did you get to enjoy any San Francisco cuisine?
We went to a ramen place after the conference, so that was nice.
Perfect. I always try to get a good burrito when I'm down there because the burritos are way better than what we have in Seattle.
Yeah, Atlanta has actually some pretty decent Mexican food, but not as good still.
Yeah, it's hard. It's hard to beat California.
Yeah.
Or probably Texas. All right, so I think we have a couple people joining in. And hey, everyone, if you're here, say hello in the chat. It's always fun to see who's watching. Also, maybe you want to put where you're watching from. And if you want to share anything else more about how you're building AI, or if you've used Flyte before, that's always awesome to hear as well. This is kind of the first of a series that we're going to keep going. That might change the name of it, but calling it like Union Office Hours or AI Engineering Office Hours with Union.ai. We're really just going to go through and do some demos and kind of share some of the cool stuff that has come out in the past like month or so, a little bit longer, maybe because this is the first one around Union. And today, specifically, also a lot about Flyte 2, which is our open source, which we'll talk more about here in a second. And specifically, I'm going to show a demo of some local development features that I find really exciting. I think everyone who has used it really likes it. We have a new terminal user interface that you see a little preview of here. We'll talk more about this in a minute. And then also, we'll probably also talk a little bit about self-healing agents. So Niels, when I mentioned, was in San Francisco. He just gave a talk on self-healing agents at the MLOps conference, right? MLOps community conference.
Yeah, that's right.
And I know there's a whole recording of that too, so it'll be cool. But if you have questions too, again, as we go, put them in the chat, and I'd love to hear kind of what you all think. And somebody said first time with Flyte. This is the first time you've heard of Flyte, or you've already been using it potentially. Let us know. All right, so I'm gonna go again just through some slides pretty quick here. A big thing is also in 2 weeks. I think it's the 16th. We're gonna be at NVIDIA GDC. And then the week after that, we're going to be at KubeCon as well with a booth, which I did not grab what our booth number is going to be. But also as part of GDC, if you're around in San Francisco or in San Jose, we have 2 events, these happy hours too. That'll be cool. I think both of them have like hundreds of people already RSVP'd. So it should be a really fun time. And then we're going to be at booth 7005 in GDC in San Jose. So if anyone's planning to be there, also let me know chat. Let us know in the chat if you want to meet up or talk about anything that you're going to see here today. And then I was going to do maybe a quick kind of intro to Flyte and Flyte 2 before we get into the local development, because like someone even said, it's their first time with Flyte. I think maybe quite a few people might be joining where they have maybe they've heard of Flyte 1, but they haven't seen version 2 in action yet. So Flyte's been around for quite some time. It's been widely adopted to build your durable AI pipelines. And I can pretty much almost guarantee that, at least from V1, you've used a model in some capacity, whether that's a large language model that was like trained in there, on social media, listening to music, self-driving cars. If anyone's using or have taken some rides on a self-driving car, you've probably used a Flyte model or a model that was trained in Flyte. Also used in a whole bunch of different verticals. These are ones that I know you probably would have interacted with, but we're also really widely used in like the healthcare space, life sciences, geospatial, and other cool places. Anything I missed, Niels?
Yeah, no, it's surprising who we find using Flyte in the open source.
Yeah, I mean, it's like thousands of companies, and because it's open source, we don't always know who's like using it. And then someone will pop in, to our Slack or something and be like, oh yeah, we use this. Like our whole like product's built on it or whatever, which is really cool to see. And I just put in this image today because we actually just redid our Flyte website. Take a look at it. I'll show you the coolest feature right now. So if you click anywhere, the dragon breathes fire.
The dragon's name is Scale.
Genius. And then, yeah, there's different snippets too. So if you're looking to get started with Flyte, you can do that. Oh, also, I didn't plan this, but I can show this little demo Flyte in the browser. So if you want to get started and I'll talk about this code a little bit more in some of the slides of like how this is structured, or maybe I'll skip it if we go deeper here. You can actually try Flyte 2 in your browser right now. Let me share the link in the chat. So this gives you a preview of the code. Again, we could talk about this more later, but we define a Flyte task environment. You're going to do this whether you're doing a local run like we're doing right here with this TUI that we're going to bring up, or if you do this with a remote run, you can add in other parameters like the compute that you want it to run on, passing in secrets, etc. And then you basically just wrap your functions inside of a task decorator from that environment. So you're writing Python like you normally would, and then you just add these decorators over the functions. This now becomes a unit of execution, like a task. And then this will get the inputs and outputs logged. Actually, let's run this. We can see it ran. We can go click into this. And then this has a whole kind of workflow tree of everything it did. And you can click into each one of these and you'll get inputs and outputs logged here. And then there's other local kind of development features that I'll talk about, but like you can generate reports and those will get saved here too. And then you can click on them and then you can review like your HTML files. So if you want to try it out, go do that. So Flyte 2, you saw a little bit of the SDK so far. This is the Flyte 2, or this is the platform in Union right now, a kind of a preview here. So if you used Flyte 1, you might be familiar that we had a little bit of a domain-specific language with Flyte 1, and it was mostly in Python, but there's a couple little things that you had to do special to get workflows running with Flyte. In Flyte 2, it's basically pure Python. You can use loops, try catches, etc., in your workflows, which is really exciting, and this makes it really great for agents as well. So you can see these giant parallel agents spinning out here, running on Flyte 2. You just can do this with async IO as well, so it makes it really, really easy for you to build anything using async and then have Flyte handle like the kind of fan out and parallelism there. And it still runs on Kubernetes. So if you're actually deploying this to a cluster, you can do on-prem or different cloud providers. And then we're going to see, again, some local development features here in a second that I'm really excited to talk about this week, where even if you don't have a Kubernetes cluster or Docker deployed, you'll get some really cool local development features that you can use right away. But this is available in Union today, and then the open source Flyte backend is coming pretty soon. And just to reiterate, so you saw this already a little bit in the code, every task, basically you start by defining your Flyte task environment. You can give it a name, you give it a image base. So in this case, it's a Debian image, and then we're just reading from requirements.txt. But you can add other features here too, like if you want to add in specific CUDA versions for libraries or apt-get or anything like that into your environment, you do this all here instead of writing like a Docker file. So basically you can configure everything from your cluster, compute, and images directly from the Python SDK really easily here. You can pass in secrets as well. And then this is where we define the compute that we would want this to run on if we are deploying remotely. So you say like how many CPUs, how much memory, how many GPUs, and you can specify what types of GPUs. By default, you can set up or you can configure a default GPU. So if you say one, this would be like a T4 or L4 or whatever, you configure that in your cluster. And then we also have a reuse policy, so you can spin up these containers and then make sure they stay hot and alive so you can rerun tasks really, really fast in them. This is awesome to use for a lot of different applications, but I've been using a lot for agents, and it's awesome because it just runs immediately after. Also important note, so you can have different tasks in different environments. So you can create multiple of these environments. So if you have different like small language models or something like that you're using for some of your agents, you could have a specific environment for that. You can have it isolated. So they don't all have to be running in the same environment, but you can reuse this as many times as you want across different tasks. And then just Flyte tasks to reiterate, like this is the kind of unit of execution, and you're going to define like your function or async function here. And then this becomes containerized. and you can run other tasks within this task. So now this is kind of where you can build out your workflows too. So if you were familiar with V1, instead of using that workflow decorator, you can use a task decorator and call other tasks from there. Strongly typed. So if you did use V1, this should be pretty familiar. We do enforce typing, and then the inputs and outputs are serialized. Everything's observable, kind of like we saw in that preview. It's all logged, it's all versioned. You can go back and see every run, what were the inputs and outputs, and then other artifacts that you generate from there. You're gonna use this async IO, and then also it's really easy to do local to remote development, and we'll dive a little bit deeper into the local part here in a second. And then this is just kind of a preview of what that platform looks like if you haven't seen it yet. So you can click around. These are actually saved reports for like HTML or Markdown from an agent running. We capture, again, all the inputs and outputs for each one here, and then logs and metrics as well. And the whole task config and code. So basically everything. This whole snapshot of the entire workflow that you ran here basically gets saved here. Anything else you want to add, Niels, real quick before I go to local dev?
Yeah, I mean, just to reiterate, we've actually done it in terms of Python, right? Like, there are a lot of orchestrators out there that have a DSL, and they do so very explicitly. So you have to learn the DSL, and it has its limits, it has its boundaries, and there's no kind of like uncanny valley in those types of orchestrators. So I call out like Metaflow. It's a class. Each step is a step thing that you decorate, and then to call the next step, it's an explicit like self.next to call the next node, right? So the benefit of that is it's explicit. You have to learn a DSL. You have to learn the structure. With Flyte v1, we try to do a thing where it looked like Python at the workflow level, but it actually wasn't. And that's actually a big lesson learned. Like, you either want to be very explicitly a DSL or very explicitly just plain Python. And so I think for the most part, we've like 99.999% of the language, it's pretty much Python, and you can build workflows as if you're just writing sync or asynchronous Python. So try it for yourself. I think that's the easiest way to be convinced. It's, you know, we can speak about it all day, but hopefully it'll like convince some folks. But yeah, try it out for yourself.
Yeah, it's really easy now to go from just whatever you're building to Flyte or Union, because again, it's actually Python. You don't have to adjust around a DSL later when you want to put something in production. Speaking about trying it, Flyte 2 SDK is fully out of beta now, which is very exciting. So it has been out for beta. The people have been playing around with it. It's been awesome. Feedback has been amazing as well. I like, people love it. So again, we're saying you should go try it though, and then, you know, let us know how much you love it. Also, if there's something you don't like, let us know as well. But you can just pip install Flyte. I recommend, if you want to see some of the cool local, or use some of the cool local stuff that I'll be showing here next with the 2E dependencies. This is going to give you that terminal user interface that we saw a preview of at the beginning. And it really becomes a awesome, lightweight, local workflow and experiment management kind of a platform that you can use in projects where you might not need like a whole cluster yet. So you go check out the Flyte SDK. I'll share the link in the chat here. And I'd also shared the Flyte website as well before, but I'll share it again. So all the information on like kind of Flyte 2 and the SDK is out now. I think there's actually a whole blog post that I could probably pull up to, or I'll share it out later. Oh no, here we go. I was like, I thought I had it up. This kind of talks a little bit more about the V2 SDK. Right, so once you pip install Flyte, you now have these really cool features, which I've been using a lot more in kind of like my lighter weight projects or personal projects even now, again, where I might not need a whole Kubernetes cluster, and I'm not exactly worried about maybe the scaling and reproducibility piece of it yet. But I really like having a awesome workflow visualizer, especially if you've been doing work with like agents that call a ton of sub agents or working with multiple agents and doing a lot of tool calls. If you're logging that, it kind of gets hard to kind of see what's going on after a while and like debugging a live run. So one of my favorite features that stood out to me right away was just having this tree, and you can see we can run this live here in a second too. But you have these like green check marks. If it fails, you get like an X. As it's running, it's blue, and then you can click into each one of these and then get those outputs and inputs here as well. So if you're doing something that's like beyond, I don't know, 4 agents or something like that, and you're running stuff in parallel, it can be really kind of confusing to see what exactly is going on and maybe even debugging that run. And this makes it really easy. And this is also cool for just larger ML pipelines, not necessarily even just agents, but it really stood out to me from doing the agent work recently with the multiple agents that, oh, I can actually finally see what's going on locally in my local runs. So you get the terminal user interface. You also get caching. So you can define a caching on a step. So we've had this like remotely as well, but now you can do this locally. So if you're rerunning a training pipeline and you don't want to download the data set or rerun that pre-processing step over and over again, you can just cache that. This is also something that was really cool for agents in production, but also debugging agents. Again, agents are on my head because that's what I've been building with. I think a lot of people have. But if you are, for example, kind of debugging and building out this long workflow, and you just want to work on that last agent piece, but you want to have all the outputs from the other ones, you could actually cache all these outputs and then just rerun the pipeline and work on that like last agent. It's also good if you are trying to optimize for not rerunning queries like at the beginning for the planning phase or something like that. There's been some cool stuff with caching and agents. And then we have reports. You can generate an HTML report. This gets saved in a local file and actually logged in that TUI as well. And you can open this up. So this is like some training runs I did recently on just like a PyTorch pipeline. And then these are going to be logged, and I can always go back into the TUI, look at my history, and pull these up as artifacts and kind of use this as a lightweight experiment tracking system now as well. And you have retries that are in there. So you can set a certain amount of retries. Like this agent actually was using the DuckDuckGo search, which is a little less reliable than some of the other paid ones like Tavily. And that fails sometimes, but you can add retries to be like 2 or 3 times. So if it does fail, where you get rate limits on the API, now it'll automatically retry that if it gets failure. And then there's some other features too, more features that I didn't explicitly call it yet for the local development. So I'll do a quick demo, unless Niels, you had something else you want to add real quick.
Yeah, I mean, you can get set up, but yeah, I'm starting to use this in my local DGX Spark.
Yeah.
So I've just been noodling around with it. I've installed Flyte, ISSH into it, and all the random things I kick off, like little fine-tuning jobs or running agents using like a local Olama server. It's all just saved in there.
Yeah.
I don't have to like roll my own little directory structure of like random experiments I've run. So it's really nice.
It's awesome. Yeah, and again, you can try this out without setting really anything up besides pip installing Flyte in your Python environment. So to start a run with that, so I already have my task defined. Oh, Kelsey said TUIs are back for the win. I think you're right. I think that's what I'm really noticing this year. I wanted to even make like a post about this or something. It's like I think 2026 is like the year of the TUI again.
We're pivoting everything back to the TUI.
We even had we have customers, I think, that love the TUI so much they want just to use the TUI for their like remote execution, because I think people are just back in the terminal all the time, right? Cloud code, etc.
Yep.
Great comment though from Kelsey. So there's some examples that you can take a look at here and run, but just to kind of call it again. So this is just a simple PyTorch pipeline. We created our task environment like we talked about in the slides, a couple of helper functions, and then we start defining our pipeline here. And here's where I pass in those parameters, like caching is equal to auto in this case. It's going to cache this unless I change any of the code here. The amount of retries for downloading the data is 2. So if it does fail downloading it, it'll automatically retry it a couple times before it counts it as an actual failure. And then we have a couple other tasks that we're putting together, like training, evaluation, And then we have our pipeline function here. We're enabling a report, which is that report that you saw generated. And then we're tying together this pipeline by calling those other tasks within this task. And then if I want to run this locally with the TUI, if you've used Flyte before, you're probably familiar with this local flag. So we just say Flyte run local. If we want the TUI, we say TUI. And then if we run this, I won't make you sit for the whole run because it does take a few minutes on my M2 chip, but this starts training the pipeline. We can actually see that this read in from cache already. So it's got this little money symbol there, read in from cache. We get the paths, and then this will show this shows the input and it'll show the output when it's done. And then we also get live logs directly in this interface as well. And if I want to exit out of the TUI, I can hit Q and it'll still be performing the run here. I'm going to go ahead and cancel that though. And let's look at my previous runs. So I can just type Flyte start TUI. And this will bring up a little interface where I can now go browse my previous runs here. So I can go filter as well. So I go click in. I'm going to go look at this previous pipeline one. And then go click in. You can navigate with a keyboard or a mouse here, by the way. And then on the right side, like we had seen before, we have those inputs and outputs logged here. And like Niels was saying, you can just install this on whatever computer you have and start using this as your kind of experiment tracking pipeline here. And then if you look, we have this report URL. If we open that up, that's where we get the experiment tracking pieces like this. And this could be really complex HTML as well. It could be like Plotly and stuff like that, and not just the super basic reports like you're seeing here.
Yeah, Kelsey has a great question here about, how should people think about Flyte now that AI agent orchestration is all about all the wave? Seems like Flyte was early on that front. It's a great question. Sage, you may have a take on this, but I think AI agents are part of software development now. It's like hard to ignore if you've tried it. Of course, there are all the caveats, and there's kind of like the long tail of languages it doesn't know well, long tail of bugs it introduces, the long tail of like bad design it introduces into your system. But I think in my experience, if you give it, I think what people are calling a harness now, like if you give it your entire code base where, historically your hopefully high quality engineering team has contributed to this code base and they've documented things, they have nice doc strings, they name the functions well, they have inline comments. A lot of these agents kind of hook onto that and usually follow the structure and conventions of a particular code base. So I think Flyte we're just modernizing it. We're simply saying, it was built at the time of machine learning, where you were training deep learning models, XGBoost models, processing data sets. Flyte's take has always been to aim for production grade, to aim for scale. And so it's always kind of been a power tool in that sense. But now I think our pivot with Flyte 2 is that all of these points are still true, but now we're focusing a lot more on the local experience, just because with agents, I guess at some point they will be running remotely, right? Like I have this vision of agents running on a Kubernetes cluster, and they're given some least access privilege to things that they need access to. But now today, practically, a lot of people trust agents a lot more when they can control them on their local laptop and the blast radius of any given catastrophic thing that happens if you happen to install OpenClaw or whatever, or even Claude Code that RMRFs an entire set of directories. Like it's not too bad, right? If it's just on your laptop. So I think, yeah, with Flyte 2, we're just kind of modernizing the developer experience to focus a little bit more on the local experience, or a lot more on the local experience, and acknowledging that AI agents are just part of this. And yeah, Sage and I are working on a lot of projects to sort of codify our learnings around how to build agents, especially in a domain like machine learning, right? So I use it day to day to build machine learning models, build batch inference systems, all that stuff. And agents are just part of it. And so there's like this funny kind of interleaving thing that goes on where we're building agents for XYZ use case. We're also building agents to build agents. We're using agents to build ML workflows, right? So I think it's just going to be part of the toolkit. And yeah, we'll see where it goes. But I think the best practices around how to really use it in the use cases where it's really good for, and then like there's always like this question of what do you outsource to them and what do you not outsource to them. Ultimately, these are pretty interesting questions. I don't know what the right answer is.
Yeah, one thing that's really cool, and actually I think Niels is going to show part of this a little bit later, is also, I think you had a turn, Niels, of using like infrastructure as context to an agent. And actually, to maybe even just set up a tiny bit, like I had some quick placeholder slides around that, even where like we already talked about like retries and all these things, and it turns out a lot of that stuff for the more traditional AI pipelines works really good for agents if you can do those things that fast, like retries, caching, etc. The kind of durability piece. One thing that's really cool with Flyte, and Niels will hammer on this more, but is kind of the error handling of the infrastructure and then doing something like dynamic recovery or self-healing. So you can actually get, like in this case, it might be hard to see with how small this is, but we get an error basically saying like out of memory because there wasn't enough memory provisioned for this agent. And we kind of saw what the code looks like a little bit. It's pretty easy for agents to understand and write Flyte. Actually, like if you give a little bit of context or pointing at the docs and use Claude, it does a great job because you saw it's basically just writing Python with a couple little things of like adding some decorators on functions and knowing how to call those things. Here, you can look for that out of memory error from Flyte and then rewrite the infrastructure with, like, in this case, it just bumps up the memory a little bit. So I think there's going to be some really cool stuff with like Flyte, the infrastructure space, orchestration around agents. We've been doing orchestration. Flyte's been around for a long time. They're really good at it. You can also run pretty much any agent framework in this. So if you look at some of the other agent frameworks that are building their own cloud and orchestration things that kind of rely on their library, you can run like LangGraph or Crew.ai in Flyte already today and get all these features that we talked about.
Yeah, it's interesting how the sort of the ease with which you can get observability out of a framework really just depends on how high or low level that framework operates at, right? So like something like Crew.ai, they abstract away a lot. And so the unfortunate thing with Flyte is that you don't actually get a lot of functional hooks to be able to decorate functions because a lot of it is kind of abstracted away for the user, and that's kind of by design. Something else like LangGraph or Pandera, it's a lot lower level in a sense in terms of the agent application logic. And so this is where Flyte observability shines. You can just add those decorators to a lot of the, I guess in LangGraph and Pandera, they call them nodes in the graph. So they've designed their SDK around the notion of graphs that are not DAGs. So these are graphs that do have cycles. And so Flyte is really good at integrating with these kinds of systems because they, the way you write their framework code is you implement plain Python functions, and then you build a graph like how Sage is showing right now. So you add these Flyte traces, which are essentially like these little helper functions that run. So these are a new concept in Flyte 2. So you have tasks which run on their own container, their own pod, and then you have traces which are invoked just as helper functions in the callee's pod, right? So if you have an agent call a trace function, it'll just run in the same pod without having to spin up a new one. So that makes it super nice to be able to productionize these kinds of agent framework applications, because as Sage said, there are the corresponding cloud hosted SaaS version of these frameworks, which provide value in and of themselves around observability, around debugging. What Flyte provides is the compute infrastructure substrate and additional durability guarantees around, this is a whole can of worms, right? I don't think we'll tackle all of these topics, but basically what Flyte gives you is like, if the agent fails at the system level or infra level or logical level, it will try again and just pick up where it left off. It doesn't have to recompute all of the tool calls and sub-agent calls that it did at the point of before the point of failure. So that's how to start thinking about these things. There's a difference between how you define the agent and like the application logic, and then the compute substrate on which that application runs.
Yeah. And like Niels had mentioned, you can add it to any point of the nodes, which is cool. So you could do just the tool, like for LangGraph specifically, like you do just the tool calls if you wanted, or agent calls. We can also do the whole node graph reasoning call, so you can see like when it decides to call end in the node, if you're familiar with LangGraph. So it makes it really easy to add like complete observability to it. With that, Niels, do you want to dive deeper into like the self-healing agent piece?
Yeah, absolutely. So I'll do a short-ish screen share. I'll do a shorter version of the talk I gave. Wow, what is that? Yesterday?
Yeah, that was
yeah. And this is really about what does the orchestration stack for observable, debuggable, and durable agents looks like. And I guess just to give you a little bit of background, here's sort of my personal agent adoption timeline, right? So in 2022, like many folks, I made first contact with LLMs that had good long-range text generation. And so they weren't agents yet. They were kind of this chat interface with ChatGPT. They could do single turn, couple turn type tasks. At some point, they gave them web search and things like this, so they can do like a single tool call of what we call tool calls now. And then 2023, I started kind of tinkering around with this technology, so fine-tuning LLMs. I had been in the NLP space before this, but LLMs are like a different beast because of their size, obviously. So played around with that, played around with building RAG pipelines, which was kind of all the rage in that year. 2024 continued just learning and prototyping. And so like built a few LangChain apps here and there for internal use cases, started using Cursor. So I migrated from VS Code to what people call as the VS Code fork, which is now, I think, sufficiently differentiated, I would say. And at that point, agents still weren't working, I would say. So I would do a lot of just tab completion vibe coding. So I'd have intent in my mind, and the tab completion models were good enough where it would, in many cases, anticipate what I actually wanted, and so I could just hit tab. Also started using things like Perplexity and Claude Desktop and stuff for non-coding tasks. Then last year, we made the decision to start building Flyte 2. And this was a result of a lot of things, feedback from users and customers who weren't necessarily building agents. So this is like the pure Python story that we were talking about before. But then we also had our eyes set on agents because I think last year was around the time they started working, and you couldn't really like ignore them. So Flyte 2 was really a response, a love letter to our customers to be like, hey, we need to make this experience building ML pipelines much more delightful, but also agents are a thing, and fully dynamic, durable, infra-aware agents, I think, will be an important part of the stack. And so here we built a bunch of internal tools. So Nodi is a fun little hackathon project we productionized that now is helping our internal customer solutions team maintain and configure our customers' node pool configurations on K8s, right? So it's a nice little well-scoped agent that works pretty well. Started looking into MCP as a set of technologies that we can potentially use to help internally. At some point, we're going to release this to the wider public. Customers started articulating use cases around agents. And I personally started using Cursor and Claude Code to do end-to-end work and do code review and fix it stuff and things like that. But and now in 2026, we're productionizing this, productizing all of our learnings, and this Flyte 2 release is sort of like the beginning of that journey. So a lot to say there. I'm gonna try to speed up here. The crux of this problem that we've learned about as we've built things internally is the agent infrastructure problem, which is you build an agent from scratch over the framework. You do a bunch of application level optimizations, context engineering, prompt optimization, getting an eval harness in place. And in development, that is like the first place you see whether your agent actually works, like semantically. Is it doing the thing you intended to do? But when you productionize things, a lot of problems crop up. And tool calls and agents, sub-agents, querying proprietary data sources require a little bit more care to set up those connections and access controls. Tools and agents that require variable compute resources fall over with single node agent runtimes. This, I think, this is a little bit of a leading type of thing. Like, I don't think today I would say like 10 or 20% of agent builders maybe encounter this, but we encounter this when building MLE agents, right? So if you have a machine learning agent that is trying to train a model, you don't want it to just have access to fixed compute. So if you have an agent that's calling sub-agents that do the ML training for you, you want the top level agent to have some way of defining what the resources are for the sub-agents. And on the similar thread, right, parallelizing sub-agents or tool calls lead to all sorts of distributed computing type problems. Containers go they're killed by the scheduler. If you're using spot instances, they're preempted by other jobs, and so you lose agent memory, you get agent memory loss and corruption, and you wipe out precious context. And so agents fail at multiple layers of this orchestration stack. And the problem isn't that agents fail, it's that that recovering from failure is challenging without the full context of how all of these pieces, infrastructure, network, logical, and semantic layers all work together so that the agent doesn't have to wait for us to debug them. They can kind of figure out themselves how to recover from failures. I'll show you concretely. I mean, this sounds like very high level and vague, but I'll show you concretely what I mean. And so agents are telling us, help me help you. This is if you remember Jerry Maguire, he was in the movie, he was like a sports agent. He was asking his client who was like a rock star, like sports, like a football player, I think it was, to help him help the football player. So agents could recover actually from infra failures. This is the prototypes and things that we've been starting to build, but only if they have the right context. So these are 6 design principles that I've sort of distilled down from all the learnings that we've had building these things internally, and also looking at our customer use cases. So 6 of them, I'll go into them in more detail, but they are basically to use a plain programming language, right? Like Python or TypeScript or JavaScript or any other one that LLM has been trained on and knows well. The second one is to provide functional durability hooks. These concretely are the task decorators and trace decorators that Sage showed you earlier. The third one is to make failures cheap. These are global caching, run level replay log. These are ways that we think about how to implement this design principle. I'll get into that later. The fourth one is these building blocks really unlock infrastructure as context, so that the agent can actually see system level errors bubbled up into the SDK, into the agent application layer, so that they can then react and, for example, request more resources. The fifth one is to equip agents with secure sandboxes, because when there's an error, that maybe there's a logical or orchestration level error, of how the agent is like putting together its tool calls. You don't want it writing arbitrary code that can do malicious things in the cases of like prompt injection, right? So you want to give it a little secure sandbox. I'll talk about two that we support where they can modify the inner loop of the agent themselves as a response to exceptions that they're getting at runtime. Then finally, you always need human in the loop as an ultimate recourse. So you typically give agents some kind of budget, so compute or iteration budget. And once they've exhausted that, then instead of just erroring out and crashing, there can be a step you introduce where it just waits for more context. And so it's in a holding pattern until a human or some external system comes in and gives it more context based on the error that it couldn't fix. So I mentioned earlier, agents break at all these different layers, right? From infrastructure to network to logical to like all the way down to context. And what we found is that a lot has been said, and there's a lot of techniques out there to solve or at least address failures at the networking down to the context layer, so those 5. But we actually didn't find much by way of people like literature on infrastructure failures. And there's still a lot of pain here that I found, at least. And one of the reasons for this is there's a context and evaluation gap. And so your evals typically test for semantic correctness. Does it hallucinate? Does it answer correctly? Are my tool calls formatted correctly? But agents often don't directly handle or reason about networking, timeouts, and failures, recovering from system-level errors, or recalling state across retries. And the insight here is that agents can actually recover from errors at all layers of the agent stack, even infrastructure level ones, but only if you give them the right context and capabilities. So context engineering is not just a data source and data connection and kind of like instruction problem, specifying the skills that the agent needs. It is all of that, but it's also an infra problem. So if a failure wipes the agent state, all the hard-earned context that you've engineered it's worthless. And so we think about durability as making it super easy to immediately resume an agent rollout where it left off, to share, i.e. not re-execute shareable workloads, the results of compute and IO or IO-bound workloads, and to save and restore state between tasks so that you have, you have a snapshot of the state of the agent as it's rolling out at each step. So all of its decisions, all of its tool calls, all of those outputs. So I'm going to talk about these 3 aspects because these are the foundations of the Flyte 2 architecture. And they allow us to implement those 6 design principles that I mentioned before. So the replay log, you can think of this as a service that records all the state of an agent and its subtasks at each step. And to generalize this for each step of an ML pipeline or a data pipeline as well, right? So if you think about a normal execution here, an agent that does a tool call, a sub-agent call, and then a second tool call where it fails, the first 2 steps that succeeded are logged in this replay log. And you can think of this as like a run level micro cache. So if there's any kind of system level error or any error in the orchestration stack that I mentioned before, then it can recover from that crash, and it'll actually replay the log up until the last completed point. And so it won't actually have to do the recomputations for those first 2 steps and just pick up where it left off immediately. So with 3 steps, it doesn't seem very cool, but with a 1,000-step agent rollout, you can start seeing why it would be nice to be able to pick up on the 999th step out of 1,000. Global caching is a similar idea as this, what I call like this fine-grained like micro cache, but it's a global cache, so it's across all agent runs. And so this is to save and not re-execute work across all agents and across all runs. And so in this example in Flyte, the way you would do this is with the caching argument and the task decorator. And so in this case, the web search tool call is cached, the db read tool call is cached, but then maybe in your application, the composer subagent that takes the outputs of these previous two tool calls and like creates a report for you. You want to create variations of those, right? And you want to keep the first two steps fixed. And so you have fine-grained control over what work of the agent is shared and is not shared. Then finally, intermediate state persistence. This is something that's been the bread and butter of V1, Flyte V1 as well. But it's just kind of just taking for granted the fact that when you do the first LLM call here, the output of that is actually saved to object store. So that's S3 or some object store like that. When you do the tool call, the same thing is done. When you do the LLM call, the same thing is done. And even with the final, composing the final answer step, all of those intermediate steps are automatically serialized and deserialized across these containers. And so, as I said earlier, this unlocks these 6 design principles that I'll try to blaze through in the next few minutes, because I do want to like show you this in action, actually. So using plain Python is, in our case, plain Python is nice because you can just use programming concepts that you're all familiar with, and agents can too, right, as they write this type of code. There are no DSL surprises. And then actually, as you'll see later, exceptions are a perfect delivery mechanism for critical context about failures at all layers of the stack. And then finally, because you're just using the programming language, and in this case in Python, you have this decorator pattern, you can easily provide functional hooks, which gets to my next point, which allows you to implement the durability pieces that I mentioned earlier of the run level replay log, the global cache, and the intermediate state persistence. And so the way in Flyte you do this, as we saw, you define a task environment, which is a configuration of the image you want to use with its dependencies and the resources that the agent will be using at the top level. The environment.task is, you can think of as containerized functions, and the trace are helper functions inside the container. So you can get that fine-grained observability and durability within a container. So this makes failures really cheap. So if you have an agent that writes code, runs that code, and then finalizes the answer, you have all these durability hooks on each step of this of the nodes in your agent loop. And so what actually happens here is failed runs become training data or additional context for the agent to learn from. And not only can you do this kind of in an out-of-band process where you kind of look at all your failures separately and you create a separate training data or like context for future agent runs, but you can actually react to them in line. So let me show you what this looks like in unlocking infrastructure as context. So infra-level context, as Flyte bubbles it up at the application level, can actually be caught. So you can catch out-of-memory errors. This is something Sage showed a little bit earlier. You can then respond to that error so that this exception string contains hopefully some information about what went wrong. And then the adjust resources tool is basically an LLM call that looks at that error and looks at the previous code potentially and spits out a resources dictionary that it then feeds back into the for loop. So it creates a new resources object that the run code step can override, right? So it can fix this, in this case, the out-of-memory error. But not all of the errors you encounter are in this kind of structured guardrailed format, right? So in this case, it's just a dictionary that you can kind of make sure that the output is formatted correctly. Sometimes the agent needs to change its inner loop, its orchestration loop of how it's composing the different tools. So this next piece is about equipping agents with secure sandboxes. The first type of sandbox I'll talk about is code mode. So code mode is where the agent writes pipeline code to orchestrate trusted tools. So in this case, you have a process data tool and a train model tool. The next piece is that the orchestration mode sandbox runs the agent-generated pipeline, which then actually dispatches tool calls to the trusted tasks, right? So this code here that the write pipeline code LLM call outputted is actually Python code, but it's using a new piece of technology called Pydantic Monty, really nice little sandbox that's super, super powerful. Can get into that later, but basically in this Rust-based Python subset, you can only do function calls and control flow. And so you can't do imports, you can't do network calls, you can't do I/O. So this coupled with Flyte is super powerful because you can actually still delegate the function calls in that code to run on a pod somewhere that Flyte is orchestrating. So you can pass around files, directories, data frames, dictionaries, other data structures safely in this code mode orchestrator sandbox, which is really cool. And then you have this really tight error iteration loop in this orchestration sandbox. Then you have a stateless sandbox, which is effectively you can think of as a container with very limited I/O and network access. And so this is useful where the agent actually, it's not an orchestration issue, it's more a logical issue, or it's more like the agent gets a task for which it doesn't have the right tools in its predefined tool belt. So what I'm showing you here is that the code sandbox runtime provides a substrate on which agents can safely build their own tools in an isolated secure container. MLE agent can write their own tools. It runs on the sandbox. It catches runtime errors that it goes into a loop to fix. And in the end, it can deploy this new tool onto Flyte. So that's where a human in the loop step comes in. So human in the loop step in this case can be used for that, like deploying code that is potentially unsafe that an agent came up with, or it could be used to provide additional context. So when an agent can't recover by themselves, this is the ultimate fallback. And so once the agent has exhausted its max iter budget, it can recursively then, it can ask for additional context here. So this is a human in the loop plugin offered by Flyte. And this will show up both in the UI, and you can hit an API endpoint to provide this additional context. And the cool pattern here is that you can recursively call the agent back, giving it more context. And so the outcome, this is the coolest slide, is that you get agents with a healing factor, right? So you get Wolverine and not necessarily Juggernaut, who is unstoppable. Agents do fall down and they do fail. And all of the measures and design principles I've said does not guarantee crash-proof agents, but they get to a pretty good place, I would say. So what you're seeing here is that, and actually I'll just show you this. So I'm gonna actually rerun this workflow. This is a very simple toy example of what I mean. And maybe I'll go to the previous run here, just as this one run is rolling out. So what happened here is you can see in the reports that this particular tool builder agent got a task. So the task it got was train a linear regression model to predict the target column from feature 1 and 2. So from a CSV file. So we're also giving it a CSV file here. Went through 5 attempts, and I've purposefully injected bugs and like failures, right, so that it can show you what it can do. But in the first attempt, there was an out of memory error over here. So it was killed, and it went back and adjusted its sandbox resources. It gave itself more memory and tried again. But there was another bug which I injected in here, which was just a division by 0 error. So it went back and it rewrote the code, removed the 0 division. And then there's yet another bug where I purposefully removed all the pandas dependencies, or the pandas dependency from its sandbox. So that rewrote the code, rewrote the dependency structure, rebuilt the image with pandas installed. And then finally added another bug here with the data, rewrote that. And actually, this might be a natural bug. Yeah, I don't think I injected this. So this actually was a bug that the agent introduced by itself. as it happens. They rewrote the code, and then this 5th attempt, it succeeded. And so at the top level agent, you can see the reports of all the code that it wrote, and the final outcome here. And I actually deployed this task. So now this task is, I should actually have a human in the loop review step in between here, but I just YOLO'd it. What do we call it? Deploy sandbox task. So that should be, oh, it's not here anymore. Okay. But that, oh, right, because this was a previous run. So this task has now been deployed, and it can be something that an orchestrator agent can then pick up and use. We're almost at time, so I think I'll kind of stop there. The last thing I'll just quickly mention is just a brief case study we did with Dragonfly, who's a customer, and they built agents on top of Flyte 2. They're building a automated solutions architect that is an agent that creates a living knowledge graph of SaaS products. So you go to Dragonfly and say, hey, I'm a team of 5. We need a Jira-like product that's more modern, let's say. We have these other requirements. And so pick a tech stack of SaaS products that you want to use, right? So this is the agent they were building. It was 250K plus software products that they needed to do deep research on. So their agent had about 200 steps per agent call and 100 LLM calls per product. So that adds up in terms of LLM calls. So they're very cost aware. So we gave them a solution of a tiered agent architecture where at the top level you had 4 replicas of an agent. Underneath that were 8 replicas of a coordinator sub-agent that took the high-level prompts and translated them into research threads that then the research layer of 12 replicas would go and do a bunch of tool calls and text-based synthesis. And below that would be the tool call layer that had 12 replicas as well. So all in all, this gives them cross-run caching. This is the global cache I mentioned earlier. So you don't have to double pay for LLM calls given the same input. They did a really cool thing that called semantic convergence detection. So the coordinator layer, every once in a while, would look at all the research threads, and they implemented this semantic similarity system that would deduplicate and collapse similar research threads. So your researchers weren't being handed, duplicate research streams. They got checkpoint-based recovery. This is all the durability stuff I mentioned earlier. So they use spot instances heavily, and on interruptions, their agents would not lose their work. And then finally, full auditability. As you saw in the UI, every single tool call and sub-agent call is traced. You can see the input and output. And the result was, we onboarded them to the system in about an hour. They got 2,000 plus concurrent research runs, reduced their failure recovery time by 50%, increased their dev velocity by 30%, and saved about 12 hours a week in terms of infrastructure maintenance. So yeah, this is the kind of a conclusion for self-healing agents. This is something that's definitely still a work in progress, but as you can see, Flyte 2 unlocks all of this. Like, this was just not possible in Flyte 1, and arguably it's something that Flyte 2 uniquely offers in the market today.
I was looking for the Google Meets clap emoji, but there's none here. Awesome. Super cool. So if you were here at the beginning, you saw us go through some of the local features. Go check out the Flyte SDK today. Even if you're just running smaller local ML pipelines or larger ones, it can be really cool for you. If you want to check out the whole Union or Flyte 2 on Union, go to Union.ai. I think we have links in the chat already for that as well. And if you want more of a demo or your own sandbox, you can reach out to us as well. If you go to Union.ai, there should be a I think we changed the wording, but it was join the beta before. Now it's, I think, try V2. So you should give it a try and let us know what you think. Also, let us know what you think of what you saw today, too. But with that, I think we're at time. I think we both have other stuff to jump to. So I think we're going to have to wrap up the stream right on time today. But if anyone has any questions, reach out to me or Niels on LinkedIn. I will also just share, I'll grab a link real quick. There's a Slack channel you can join the Slack community and ask any questions there as well. There's well over 5,000 people already in there too. So it's a fun, strong community to join and ask your AI questions in.
Awesome.
Oh, hopefully I'll talk to some of you all there.
Yeah.
Thank you, Niels.
Okay. Thank you. Bye.